the memory management and develop this schedule. Also we said about the file system implementation. So what is this file system? What are the different operations we can perform on the file system? So what is the file system structure? So like we have different structures of the file system, like this schedule, and we studied what are the different access controls of the file system. So we have this owner, then a group, and unit. So these are the access controls of the file system we studied. What are the different types of access to the file system we can perform? Read access, write access, then execute, append, then delete, and list. So all these are the different types of access which we can perform with the file system. Okay, so that we understood in the last class. So now we go for the next topic, that is the file system implementation. So in the file system implementation, file system structure, this provides bulk of secondary storage which file system maintains. Okay, so this file system structure contains so the memory space and the secondary storage device, so where actually our file system is completely stored. And after that, the disk is suitable medium for storing the multiple files. Okay, so the hard disk, whatever we use, so it is the suitable device. Okay, so to store the multiple files. So this because the disk can rewrite in place. Okay, so the disk can be used for reading and writing. That is possible in the hard disk. It is possible to read a block from the disk, okay, so modify the block of data, then write a block into the disk. Okay, so all these are some of the disk operation which we can perform. So we can read a block of data. Okay, so it may be file, it may be any other kind of data. So I want to read a block of data. Okay, so that can be done. Then after that, modify the block. Okay, so I want to modify a block of data, so which is already inside the disk. So that is also we can do. Then after that, the writing onto the disk. Okay, that is also possible. The second one is this can access directly and block of information. Okay, so this can be accessed directly any block of information. Okay, so that is also one of the advantages of using this disk. It is possible to access the file either sequentially or randomly. Okay, so the file accessing either sequential accessing or random accessing, both is provided. Both options are provided by the disk operation. Not only that, switching from one file to another requires only moving of a rewrite head. Okay, so I want to switch from one file to another. I want to access one file to another file. Okay, so that is very simple, very easy to access. So just so we are moving the rewrite head and we are trying to access the one file. Okay, so if I want to access another file, okay, so just is a matter of just moving the rewrite head. Okay, so inside the disk. Next one, the important IO efficiency. Okay, the one more important advantage of using this hard disk, okay, disk space. Okay, it improves the efficiency of IO operation. Okay, IO transfer between the memory and the disk are performed in the units of blocks. Okay, so I want to transfer any of the data, so from the disk to the memory. Okay, so that is performed in the form of a unit. Okay, so unit of data is transferred at any given point of time. So which is a operation, or which is how the disk operates the how the disk works with the files. Okay, next one, each block has one or more sectors. Okay, so that block what we transfer between the memory and the disk, okay, it contains one or more sectors. Depending on the disk drive, sector size varies from 32 bits to 4096 bytes. Okay, so depending on the size of the sector, depending on the disk drive, okay, it varies from 32 bytes to 4096 bytes. Okay, so that is the size of the block. Okay, next one, the usual size is, okay, so 512 bytes. Okay, the usual size of the block, okay, so which we transfer between the memory and the disk is the 512 bytes. Okay, the file system provides efficient, convenient access to the disk size, allowing the data to store. Okay, so what is this file system advantage? What is the file system provides the efficient access. Okay, and provides the convenient access to the disk, by allowing the data to be stored. Okay, so design problem of the file system. So what are the design problems we come across inside the file system? The first one is defining how the file system should look to the user. Okay, so that is the first problem. Okay, the first design problem of the file system is, okay, so defining how the file system should be looked to the user. Okay, so when the user want to see, okay, so user want to work with the file system, so the design of the file system should be in such a way that, okay, so the designing is very very important. The file system, what is the user requirement, and what user expects. Okay, so as per the user expectation, as per the user requirement, are we design the file system. Okay, so that is very very important. Next is creating the algorithm and data structure to map the logical file system onto the physical secondary storage device. Okay, so this is also very very important. So creating a data structure. Okay, so creating a data structure which maps the logical file system onto the physical secondary storage device. Okay, so this is second the challenge. Okay, so design problems to inside the file system. The file system itself is generally composed of many different levels. Okay, it's generally composed of many different levels. The file system. Okay, so layered file system. Okay, so the first next point is a layered file system. Levels of the file system are shown in the diagram of 4.26. Okay, so as you can see here, the levels of the file system are shown in this layered file system. So there is a application program, there is a logical file system is there from the application program. Then from the logical file system, there is a file organization, a module is there. So from the file organization module, we have this basic file system. From the basic file system, we have this IO control. From the IO control, we have this devices. Okay, so like this, the layered file system. So it is shown in this diagram. So then what is this layered file system means? It contains IO control that is called as a low level control, okay, which performs the controlling of the IO operation, which performs the controlling of the hardware section of the computer. Okay, consists of device drivers, it consists of device drivers, it consists of interrupt handlers to transfer the information between the main memory and the disk. Also, it contains the device drivers can be uh, uh, for use it for the translators. It will input consists of high level commands. Next one is called as a basic file system. What is the basic file system? Need only to issue basic commands, okay, to the appropriate device drivers. Because I want to issue any basic command to the device drivers. So all these appropriate commands, okay, so that you can store inside the basic file system, and rewrite a block onto the disk. Okay, so all this done in the basic file system. Next is called as the file organization module. Okay, so what is the file organization module? As the name says, the file organization module means the organization of the file is completely controlled by this file organization module, known about the file and their logical and physical blocks. Okay, so clearly the logical and physical blocks of the file organization. So that is clearly defined inside the file organization module. Not only that, they translate the logical block address into physical block address. Okay, so translating of the logical block address to the physical block address, that is carried out inside the file organization module. Next one is called as a logical file system. What is this logical file system? Manages the meta information about the file. Okay, so that is the meta information or metadata includes all the file system structure except the actual data. Okay, so the meta information is completely the data about that particular file. Okay, so and the management of this meta data, okay, or meta information. Okay, so that is done inside the logical file system. Okay, so manage the directory structure. Not only metadata managing, okay, also manages the directory structure. Okay, it maintains the file structure via the FCD. What is FCD means? FCD means a file control block. So to control the files, okay, so there is a one data structure maintained that is called as a file control block. The file control block contains information about the file, okay, which includes the ownership of the file, which includes the permissions of the file, which includes the location of the file, okay, so volatility state. The advantages of this layered structure is the duplication of the code is minimum. Okay, so the duplication of the code is a very very minimum. Okay, it's completely controlled. Okay, it is minimized. Next one is called as IO control can be used by multiple file systems. Okay, so that is also one of the advantages. Okay, so this is the diagram. So we go for the next topic that is called as a file system implementation. Okay, so we studied the layered file system. So now we go for the file system implementation. Okay, inside the file system implementation, the overview of the file system implementation is on disk and in memory structure are used to implement the file system. Okay, so we can implement the file system on the disk, so we can implement the file system on the memory. Okay, so on disk structure includes, okay, so the implementation includes, okay, so showing the diagram for example 2.7, so file permissions will be there, then file data will be there. Okay, so the file owner group and ACL will be there, the file size will be there, the file data block or pointer to the data blocks will be there. Okay, so all this comes under, okay, so the comes under a typical file control block. Okay, so this one in this small diagram. Next one, the boot control block is there. So what is this boot control block? Contains information needed to boot the operating system from the partition. Okay, so from the partition, if the operating system has to be loaded into the our memory. Okay, so that is that is called as a booting of the operating system. Okay, so the all the information about this booting, okay, will be there inside the boot control block. It is typically the first block of the volume. Okay, so inside the disk, the first block of the volume. Okay, the first block of the complete entire memory. Okay, so it is stored. It contains the boot control block. It is called the boot control block. Contains information about the operating system loading, operating system booting. Okay, so next one is in UFS. It is called the boot block. Okay, so it is also called as a boot block. Then in NTFS it is called as a partition boot structure. Okay, so there is the partition is done. Okay, so inside the memory, either we can use a UFS, we can use this NTFS partition. Okay, in NTFS it is called as the boot structure. Okay, next one is called as a partition control block. Okay, so what is this partition control block? What it contains? It contains the partition details like a number of blocks, the size of the blocks, the free block count. Okay, in UFS this is called as a super block. Okay, in NTFS it is called as the master file table. Okay, so the master file table in NTFS and the super block in the UFS it is called. It contains the number of blocks, it contains the size of the block, it contains the free block count. Okay, so all the information will be there inside this the partition control. Next one is called as the directive structure. Okay, the directive structure contains used to organize the file. Okay, the directive structure is used to organize the file. In UFS, this includes the file name and associated number. Okay, associated inode number. Okay, so in UFS, this includes the file name. Okay, so with that, it also contains the inode numbers. Okay, so that is stored inside the directive structure. Okay, so next one is called FTB, file control block. The file control block, as I said, it contains file partition information, it contains the owner's information, it contains file size information, it contains location information, it contains the data block information. All these things will be there inside the file control block. In memory structure are used to both the file system management and performance improvement via the structures in place. Okay, so what are the different in memory structure? So it contains both file system management, it contains both performance improvement. Okay, so what is the structure of this memory is it contains in memory mount table. Okay, so it contains in memory mount table, it contains in memory a directive structure, it contains the system wide open file table, it contains pre-processed open file table. Okay, so what is this in memory mount table? It contains information about each mounted partition. Okay, so all the mounted partitions and the information about the mounted partitions will be there inside the in-memory mount table. Okay, next is called as in-memory directive structure. Okay, so it shows the directive information are of recently accessed directives. Okay, so all the recently accessed directives, the information will be there inside the in-memory directive structure. Next is called as a system-wide open file table. Okay, so what is this system-wide open file table? It contains the copy of the FTB, okay, of each open file. Okay, the FTB means our file control block. Next is pre-processed open file table. Okay, it contains the pointer to the appropriate entry in the system-wide open file table. Okay, so that is how So all the information about the file and directory and about the file control block, okay, so it will be there. So inside this memory structure. Next one is called as buffer. So buffers hold the file system blocks. So when they are being read from the disk or right onto the disk. Okay, so buffer I use it to hold the information about information with the file system. So when they are reading from the disk, when they are writing onto the disk, all these things information will be there inside the buffer. To create a new file, a program calls the LFS, logical file system. Okay, the LFS know the format of the directory structure. Okay, so from the LFS we can know the format of the directory structure. So in which we want to create a file. To create a new file, the LFS allocates a new FTD, that is our file control block. And after that, read the appropriate directory into the memory. So in where, okay, so we want to create a file, then update our LFS. Okay, so after updating LFS, okay, so this is the logical file system, then write LFS back to the disk. Okay, so after creating the file, the updated whatever the LFS is there, so that need to be copied again onto the disk. Okay, after that, after the file has been created, it can be used for IO. So after the file has been created, it can be used for the IO. That is called IO operation. The file must be opened. Okay, to perform any IO operation, so we should open the file. Next is the FTP is copied and the system-wide file table memory. Okay, so the FTP will copy the file control block is copied onto the wide open file table. Next is an entry is made in the pre-process open file table with a pointer to the entry in the system-wide open file table. Okay, so that is one more thing. And after that, the next operation is the open call returns the pointer to the appropriate entry in the pre-process file system table. Okay, that is the next point. All the file operations are performed by the pointers. Okay, so any file operation we want to perform, so that is done using the pointers only. So when the process closes the file, the pre-process table entry is removed, the system-wide entry opens pointer decrement. So like this, so many different pointers are involved, so many different operations are involved to perform any of the IO operation with the file. Okay, so their involvement of FTP will be there, involvement of our preprocessor will be there, with involvement of our file pointer will be there. Okay, using all these different the parameters are using the different attributes, okay, so we can perform the IO operation with the file. So that is action in this small diagram. Okay, so in the memory file system structure, the file open and a file read operation, that is shown in this diagram. Next is called as a partitioning and mounting. So what is partitioning and mounting? Disk layout can be a disk can be divided into multiple partitions. Okay, so I want to divide the given disk into multiple partitions. That is possible. Next one is a partition can span multiple disks. Okay, so it means so for each and every partition, multiple disks. So we can treat each and every partition as a multiple disk. Okay, each partition can either be raw, okay, or it will be boot information. Okay, so means so it's containing a number of file system. raw means that is containing number of file system or that contains the file system. The boot information is a sequential series of blocks loaded as an image onto the memory. So the execution of the image starts at the predefined location. Execution of the image starts in the predefined location, such as the file, such as the first byte. The boot information has its own format because at the boot time the system does not have any device drivers loaded. The system cannot interpret the file system format. The steps for mounting. Okay, what are the different steps we use for mounting? The steps for mounting is the first one is called as a root partition contains the kernel in the mount at the boot time. Second is the OS verifies that the device contains the valid file system. Okay, so before mounting, the OS should verify the device contains a valid file system. Finally, the OS now limits memory and table structure that the file system is mounted and the type of the file system. This is called as a virtual file system. So The OS allows the multiple types of file system to be integrated into a directory structure. Okay, the OS allows the multiple type of file system to be integrated into the directory structure. Three layers are there. Okay, so what are the three layers? First is called as a file system interface. Okay, second is called as a file system interfaces. The third one is called as a local file system. Okay, so the virtual file system, okay, it contains three different types of layers. So file system interface. Okay, so this is based on the open, read, write, and close all of the file description. Okay, so the function which we use in this file system interfaces is on. Okay, so based on the opening of a file, based on the reading of a file, based on the writing onto the file, based on the closing of the file. Okay. Next is called as a file system interface. Okay. So the file system interfaces. So this service the two functions. Okay. What are the two functions? The separate file system basic operation from their implementation by defining a clean VFS interface. Okay. So separation of the file system basic operation from their implementation. Okay, so implementation and the basic operations are clearly separated in the file system interfaces. Okay, so which is called as a VFS. Okay, and next one is called as the VFS is based on the file representation structure called as a VNode. Okay, so the representation structure using a VNode, it is done in the VFS. A VNode contains a numerical designator for the network network wide Unix file. Okay, so that is the information. Okay, the network wide Unix file information is there inside the VNode. That is called as the local file system. So what is this local file system? The local files are distinguished according to the file system type. Okay, so local files are distinguished according to the file system type. The file system interface, okay, so then after that the VFS interface will be there, then the local file system will be there. Okay, so as shown in this small diagram. This is the schematic view of the virtual file system. Okay, so the three different parts of the virtual file system shown in this small diagram. So next is called as the directory implementation. Okay, the directory implementation contains the linear list and a hash table. So what is this linear list? Okay, the linear list it contains two things. One is called as a linear list and a hash table. The linear list, which is a linear list means list of file names has pointers to the data blocks. The pointers to the data blocks. Okay, so that is called as a linear list. To create a new file, the first search for the directory to be sure that no existing file has the same name. Okay, so that's the searching we have to do. Then add the new entry unto the end of the directory. Next one, to delete a file, search in the directory for the named file. Okay, then use the space allocated to the file. Third one is to reuse the directory entry. There are three solutions. First one is called as mark the entry. Next is called as attach the entry. The third one is called as copy the last entry. Okay, so that is a three different operation to be performed just to reuse the directory. The problem is finding the file sequence and the linear search which show the execution. Solution is a cache memory can be used to store the most recently used directory information. The stored list allows the binary search and decrease the search time. Advantage is simple to program. Disadvantage is time consuming to the execute. Okay, the hash table. So next is called as hash table. The linear list stores the directory entry in addition to the hash data structure. We also called as a hash table. So hash table has takes the value completed from the file name and return the pointer to the file name in the linear list. Advantage is decrease the directory search time and insertion and deletion are easy. Disadvantage is some various some versions must be made for solution. Okay, so the next one disadvantage is fixed size of the hash table and the dependency of the hash functions and the size. Okay, so these are some of the advantage depending on the table. Okay, so we have the allocation methods. Okay, so the allocation methods and the continuous allocation. Okay, so that we see in the next class. Okay, so thank you.